JEE Advanced 2021, Paper 1, Question 7. Physics RC Circuits. Let us visualize the circuit. We have a switch S that can be at position P or Q. From switch S, a 1 ohm resistor connects to node A, and then a 2 ohm resistor connects to the right terminal. A 1 volt battery with its positive terminal on top connects between position P and the ground rail. A 2 volt battery connects between the right terminal and ground. A 1 microfarad capacitor connects between node A and ground. When switch S is at position P, current flows through both resistors. With switch S at P, let us see the current flow. Current flows from the 2 volt battery, through the 2 ohm resistor, to node A, then through the 1 ohm resistor, and back through the 1 volt battery. At steady state, no current flows through the capacitor. The question asks, in the given RC circuit, when switch S is at position P and the circuit has reached steady state, find the magnitude of charge Q1 on the capacitor, in microcoulombs. The key concept, at DC steady state, no current flows through the capacitor. It behaves like an open circuit. So the charge on the capacitor equals capacitance C times the voltage at node A. We need to find the voltage at node A using the resistive network with the batteries. Step 1. With switch S at position P, the 1 volt battery is connected into the circuit. We have a single loop. The 2 volt battery drives current through the 2 ohm resistor, through node A, then through the 1 ohm resistor, and back through the 1 volt battery. The two batteries oppose each other. Step 2. Calculate the current. The net EMF is 2 volts minus 1 volt, which gives 1 volt. The total resistance is 1 ohm plus 2 ohms, giving 3 ohms. By Ohm's law, the current I equals net EMF over total resistance, which is 1 over 3 amperes. Step 3. Find the voltage at node A. Starting from the 1 volt battery side, voltage V at A equals 1 volt plus current I times resistance R1, which is 1 plus 1/3 times 1, giving 4/3 volts. We can verify from the 2 volt side, V at A equals to minus 1/3 times 2, which also gives 4/3 volts. Both methods agree. Step 4. The charge on the capacitor. Charge Q1 equals capacitance C times voltage at node A. Substituting, Q1 equals 1 microfarad times 4/3 volts, giving us 4/3 microcoulombs, which is approximately 1.33 microcoulombs. The answer is, the magnitude of charge Q1 equals 4/3 microcoulombs, approximately 1.33 microcoulombs. To summarize, the current was 1/3 ampere, voltage at node was 4/3 volts, and the charge on the 1 microfarad capacitor is 4/3 microcoulombs. Exam tips for JEE Advanced circuits. Tip 1. At DC steady state, a capacitor is an open circuit with zero current through it. Tip 2. Find the voltage across the capacitor from the resistive network, then use Q equals C times V. Tip 3. Always verify voltage at a node from both sides of the circuit. And tip 4. Watch battery polarity, it determines the direction of current flow. If you found this helpful, like and subscribe for more JEE Advanced 2021 solutions at MAGPIEHUB.